So now that we've looked a little bit at counting, and again, I feel so silly saying that, but now that we've looked a little bit more at counting, let's look at advanced counting. It still sounds really silly to me. Uh, but one of the ways that we can look at that is permutations. So before we get into what a permutation is, let's look at a couple of different situations. So for part A, how many different ways can a coach line up her 6 players? Well, just like last time, we could count out. We can do every single possibility. 1, then 2, then 3, then 4, then 5, then 6. And then 6, then 5, then 4, then 3, then 2, then 1. All those different possibilities. But really the idea is when you first start, you have 6 different players to choose from. You can choose 1, 2, 3, 4, 5, or 6. And then you choose one of those. We don't care which one we choose. We just know that we choose one of those. So how many do we have left? Well, we had 6. Now we've got 5 to choose from. But now for the next slot, we only have 4. And then for the next slot, we have 3. And then we have 2. And then last but not least, we're left with that one more that we can put in there. So really, this is that same idea that we used for that counting principle. But now we're just taking one away every time. Because we had 6, then we picked one of them. Then we had 5. And then we picked one of those, and we had 4. Picked one of those, 3, picked one of those, 2, 1, all that. And when you multiply all those together, you end up with 720 different ways. Now we as mathematicians realize that it takes a long time to write all that out. So we came up with a different way of writing 6 times 5, 4, 3, 2, 1. We call it 6 factorial. So when you first see that, a lot of people think it means 6. But no. That means 6 times 5, 4, 3, 2, 1. And there's actually a button on your calculator for it. If you have a TI-83 or a TI-84, if you hit math, which is below alpha, which is below second, so that top left of your calculator, if you hit math and then scroll to the right until you get to probability, it's going to be right down there. It's that exclamation mark. So you can multiply in your calculator 6 times 5 times 4 times 3 times 2 times 1, and you'll get 720. Or you can type 6, go to math and scroll over, hit enter on that exclamation mark, and then now you're going to end up with that 720 as well. So there's a little bit of a quick idea of how to get those factorials going on. But long story short, this coach can line up her players a lot of different ways. And I told you guys don't count it out. You're more than welcome to, but it's going to take you forever if you try and actually count out all 720 different possibilities. And I'll be honest, you're probably going to make a mistake. Not just you guys, anybody. It's really hard to list out 720 different possibilities. So part B brings up something interesting here. Because now we only want to give the top 3 players awards. So we want to give them basically first, second, and third place. So this coach at the start of it, they have 6 different players to choose from. Now, yeah, there's probably going to be scoring and things going on, but let's just go ahead and say it's randomly chosen. So there are 6 different players that they could choose. After they choose the one for first place, it ends up being 5 different players. And then they choose second place, and they end up with 4. And that's all we care about. All we care about is 6 times 5 times 4. Because that'll give you your first place, your second place, and your third place. We're not worrying about ordering the rest of the people. All we care about are those 3 places there. So 6 times 5 times 4, 6 times 5 times 4, it's going to be 120. So there are 120 different combinations for her to give out that first, second, and third place. Now, if you've already started reading that third problem, your eyes are probably bulging a little bit. Because now you have to count out a lot of different stuff here. But let's think about what we did. So we started with our 6 people. So if we take 6 factorial, so really that's 6 times 5 times 4 times 3 times 2 times 1. But we don't want all that stuff. We want to get rid of this 3, 2, 1. So we would need to divide by 3 times 2 times 1. But how can we come up with some sort of algorithm or equation that'll allow us to do that over here? Well, we can divide by... Well, hold on, because we needed to choose 3 people there. So we had 6 people to choose from, and we took away 3 of those people. So this would give us that 3 there, but now we need to worry about the 2 and the 1. So factorial. It turns out that this right here is your permutation formula. So a permutation is used specifically when there's no repetition allowed. Once we chose that first place, we weren't allowed to choose that same person for second place. I feel like it's a little unfair to pick the same person for first, second, and third, so that's why we took them out of the running. That person already got first place, so they can't get second. The other 2 people already got first and second place, so they couldn't get third place. So this was us deriving the actual formula for permutations. Permutation formula is n factorial over n minus r, close parentheses, factorial. Where n and r are going to show up, and this is going to look a little bit confusing at first, but I'll walk through it, as npr. Sometimes you'll also see it written as p n comma r. But n, let me go ahead and switch colors right here, n is going to be the number of things you choose from. So your number of choices. And r is going to be the actual number of things you choose. So the number of things chosen. So now looking at C. Now her team is quadrupled. She's got 24 players on this team now. So I don't want to actually have to multiply out that 24 times 23 times 22. It's not that bad, but let's go ahead and see if we can get our equations to figure it out for us. So for part C, we have 24 things to choose from. So n PR, we have 24 things to choose from, and we're actually only picking 3 of them. So plugging into the formula gives us 24 factorial divided by 24 minus 3 factorial, which again, when you actually multiply it all out, and if you were to write it all out on a piece of paper, it's not going to take that long. Yeah, you're going to have to write out 24 numbers, and it's going to be a huge pain, but life goes on. Once she has 24 players, you end up with 12,144 different combinations. That's a lot of different ways that they can choose first, second, and third place. And if you went through and you actually punched the 24 factorial divided by the quantity 24 minus 3 factorial on your calculator, it's going to take you a little bit to plug all that in. So again, if you have a TI-84 or a TI-83, then there's a button, there's a built-in function here, and it's under that same menu as the factorial. If you hit Math and then you scroll over to Probability, you see that NPR, where you can actually plug in the number of things you have to choose from, and then the number of things you actually choose. So again, permutations are specifically used when there's no repetition allowed. Once somebody's chosen for something, or once something is chosen, it's gone. You're not allowed to choose it again. And that formula is going to be the number of things you can choose from divided by the quantity, the number of things you can choose, minus the number of things you do choose, factorial.